1.6, solving absolute value equations. We've talked about absolute value a little bit, correct?
Yeah.
What's absolute value mean?
How far a number is away from zero?
Very good. The distance a number is from 0. Today, our absolute value bars are going to be in an equation. Okay? So let's talk about something real quick. So what do I always know about an absolute value? Is that my number always going to be positive or negative after I take the absolute value?
Positive.
Always going to be positive because our distance will be positive, correct? So let's say I give you this equation right here. The absolute value of x equals 5. What number would make that equation true?
Negative
5, right? If I plug 5 in to my absolute value, what's the absolute value of 5? 5. Does 5 equal 5? Yes. So I know x equals 5 is a solution. Is that the only one? What else? Negative 5. If I plug negative 5 in, what's the absolute value of negative 5? 5. Does 5 equal 5? Yes. Are those the only two numbers?
Yes.
Yeah. Those are the only two numbers that make this equation true, right? How many do I have?
2.
2. Most of the time when we're solving absolute value equations, we'll have 2 answers. We have to account for that positive value as well as that negative value. Does that make sense? Because when we're solving an equation, we want all numbers that satisfy that equation, right? So absolute value, we got to account for that positive value and the negative value. Does that concept make sense to us? This means yes, this means no. So do we all understand that concept? Okay, let's move on. An absolute value equation is an equation that contains an absolute value expression. You can solve these types of equations by solving 2 related linear equations. We use the 2 equations, once again, to account for our positive value and our negative value. Okay? So, this first little part, these are just some properties of our absolute value, so let's go through those. Let a and b be real numbers. Then the following properties are true. Absolute value of a is greater than or equal to 0. Absolute value is always going to produce a what kind of number? Positive. So it'll always be greater than 0, right? Or, if my a value is 0, it would be equal to 0. So absolute value of a will always be greater than or equal to 0. Does that make sense? Okay. Property number 2. The absolute value of negative a equals the absolute value of a. So if my a value is 5, absolute value of negative 5 is equal to the absolute value of 5, right?
Yes.
They're both the same distance from 0. Everyone understand that one? Okay. Property 3. Absolute value of a times b equals the absolute value of a times the absolute value of b. So if I multiply first and then take the absolute value, that's going to be the same thing as if I take the absolute value of each number first and then multiply. Okay? Because this absolute value right here, no matter what I get from my multiplication, my product, the absolute value will turn it positive, correct? Over here, if one of my numbers is negative, it'll turn it positive before I multiply. So we'll get the same product either way. Does that make sense? And then number 4 is very similar to that. It's just division. Absolute value of a divided by b equals the absolute value of a divided by the absolute value of b, as long as b does not equal 0 in this case, because I cannot have b in the denominator of a fraction. Okay? Are there any questions about any of these 4 properties? Those all make sense to us. Yes? The first one? So, a is just a real number, right? Any real number. So that could be any negative number, 0, any positive number, right? If I take the absolute value of any number, that number is always going to be greater than or equal to 0. It's always going to be a positive number when I take the absolute value, or equal to 0. Does that make sense? Okay. Any other questions on my properties? Okay. I want you to write this last paragraph down. You need to have this in your notes. You need to have it. I cannot zoom in. I don't know why. Please try your best to see it. This is directly from the book. So if you need to look in the book later on to get this, you can.
Like that whole thing at the bottom?
Yeah, it's all in the book.
The when C is less than 0?
You need all of it. You need all of it. To solve the absolute value of ax plus b equals c when c is greater than or equal to 0. So c needs to be greater than or equal to 0. Solve the related linear equations. So I can create two equations when c is greater than or equal to 0. That's very important. Okay? And then these are the forms of my two equations that I'm going to set up and solve. So you need these as well for sure. What do we notice about this first equation compared to my original equation? This first one that I underlined compared to my original.
There's a line thingamajiggy.
Very good. I think you guys are saying the same thing. It's the exact same as my original equation, just without the absolute value bars, correct? So when I'm setting up my first equation for an absolute value equation, it's always going to be the exact same, just without the bars. Okay? I'm sorry it's really small. I don't know how to make it bigger. Sorry. What do we notice about our second equation or in our original?
The A and B are separate.
About this equation in our original?
The C is negative.
Very good. It's the exact same as the first equation that I wrote, except my C value is negative, correct?
Yeah.
Now remember, we set up these two equations to account for the positive value as well as the negative value. Okay? So anytime we have an absolute value equation, we're going to set up these two equations whenever C is greater than or equal to 0. Okay, this second part of the paragraph is equally important. When C is less than 0, what numbers are less than 0?
Negative.
Negative numbers. So when my C value is negative, the absolute value equation, absolute value of ax plus b equals c, has no solution because absolute value always indicates a number that is not negative. Absolute value will always make a number positive, correct? So if I have an absolute value set equal to a negative number, that can never happen, right? Because no matter what I plug in, that absolute value is going to turn it to positive. A positive number will never equal a negative number, correct? So if my absolute value is set equal to a negative, I have no solution. Does that make sense? Okay. Like I said, I apologize for it being so small, but this is directly from your textbook. Are there any questions about any information on this slide at all? Yes?
Can you explain number 3 again?
Number 3. So if I have the absolute value of a product, so two numbers being multiplied, that's the same thing as if I took the absolute value of each number and then multiplied them together. Okay? So let's say A is negative 3 and B is 4. So for the first half right here, absolute value of AB, that'd be absolute value of negative 3 times 4. It's telling me to multiply my numbers first and then take the absolute value. Okay? So what's negative 3 times 4? What? Negative 12. What's the absolute value of negative 12? 12. Okay? That's the same thing as if I were to take the absolute value of the numbers first and then multiply them. So what's the absolute value of negative 3? 3. What's the absolute value of 4? And 3 times 4? 12. You get the same answer, correct? So I can either multiply the numbers first and then take the absolute value, or I can take the absolute value of each number first and then multiply. Okay? And then number 4 is very similar. It's just with division instead of multiplication. Okay? Can I go ahead and move on? Okay. Solve each equation. Graph the solutions if possible. Solve each equation. Graph the solutions if possible. Letter A. Absolute value of x minus 4 equals 6. Absolute value of x minus 4 equals 6. Can anyone help me out here? Setting up my two equations. On the previous slide, what did we say about our first equation compared to my original equation? Over here. How does the first equation that I have compare to my original?
The bars,
What about the bars?
they both have them.
My first equation here compared to my original. What do we notice?
The bars.
Yeah, my first equation, it's the exact same as my original, just without the bars, correct? So, if that's the case, what's going to be my first equation for letter A?
Take off the bars.
Take off the bars, so what's it going to be?
X minus 4%.
X minus 4 equals 6. There we go. Your first equation will just be the exact same without the bars. Everyone got that?
Yes.
Okay. What did we notice about our second equation compared to my first? Huh? C is negative and the bars are gone, right? So what's my second equation going to look like here for letter A?
3x plus 1 equals
For letter A.
-5.
For letter A.
Oh.
X minus 4 equals -6.
There we go. Any questions or confusion on where I got my two equations? This is the format we use every single time. The first equation is the exact same without the bars. Second equation is the exact same without the bars. My C value is negative. Remember, this is us accounting for that positive value and that negative value that we talked about on the very first slide. Okay? Now that I've set up my two equations, I can now solve these two equations and get my two answers. How do I get x by itself on both of these?
You add
Add 4 to both sides on both equations. So on the left one, I get x equals, what's 6 plus 4? 10. The right equation, I get x equals negative 6 plus 4. What does that give me? Shh, quit talking. Negative 6 plus 4?
-2.
Negative 2. So there's my two solutions. X equals 10, x equals negative 2. Let's plug them in. I'm not going to plug them in on the screen. I'm going to plug them in and just talk you through them and see if we get a true statement. Plugging 10 in, what's 10 minus 4? 6. What's the absolute value of 6? 6. Does 6 equal 6?
Yes.
There we go. This one checks out. Everyone okay with that? Plug negative 2 in. What's negative 2 minus 4? Negative 6. What's the absolute value of negative 6? 6. Does 6 equal 6? Yes, so they both check out. I found the two values of x that make my equation true. Is there any question how we got there? Okay. Next part of the directions say graph the solutions if possible. We're just going to graph on a number line. What's my first x value? 10, so I'm putting a point at 10 on my number line. What's my second x value? Negative 2, so I put a point at negative 2 on my number line. There's my graph. Questions there? Yes?
Do you have to graph every single one?
If it tells you to, yes.
Do you have to make like every single like two solutions for every single one?
Yes and no. If our C value is greater than or equal to 0, then we can set up our two equations. Okay? If our C value is less than 0, we get no solution. So we're not going to set up any equations. Okay? So what are we confused about?
I don't really understand this. Like, the character concept.
Say it again.
I don't really understand anything of it.
Anything at all? Okay. So our C value was greater than or equal to 0, right? If that's the case, and I have an absolute value equation, I know I'm going to go straight to setting up two equations. First equation will look the exact same, just without the bars. Second equation is the exact same without the bars. C value is negative. Okay? So over here, x minus 4 equals 6 is my first equation. Exact same without the bars. Second equation, C value is negative. X minus 4 equals negative 6. Because remember, absolute value, I've got to account for that positive and negative value that makes the equation true. Okay? Okay. Let's look at letter B. Absolute value of 3x plus 1 equals negative 5. Can someone help me out here? Yep.
3x plus 1 equals negative 5.
Okay. What else? Yep.
When we do the second one, would you change the negative 5 to a positive 5?
Okay. There's my two equations, right?
Yep.
Okay, what's my first step on each of these to solve them?
Take away 1.
Subtract 1 from both sides. Negative 5 minus 1? Negative 6. 5 minus 1? 4. Be okay with that step on each equation. After we set up our two equations, it's just solving equations, which is what we've been doing past 2 weeks now, right? What's my next step on each equation?
You divide.
Divide by 3 on both sides. On the left, x equals negative 6 divided by 3? Negative 2. On the right, can I simplify 4/3 at all? No, so I'm going to leave it like that. So there's what I'm saying my two solutions are. Let's plug them in and see what happens. Plug negative 2 in. 3 times negative 2? Negative 6. Negative 6 plus 1. What?
6. Wait.
Negative 5?
Oh,
What's the absolute value of negative 5?
5.
5. Does 5 equal negative 5?
Yes.
No, it doesn't, does it? Uh-oh.
Wait, what?
Negative 2 didn't work, did it?
Wait.
I plugged in negative 2. 3 times negative 2 is?
Negative 6.
Negative 6.
Plus
Negative 6 plus 1.
one. There's negative.
Negative 5. Absolute value of negative 5? Positive 5. Does 5 equal negative 5?
I heard plus 7. Like 7.
No, we don't have a 7 up there.
So how is that equation gonna have
Wait,
a
so how
solution?
did
Hold on. We're getting there. We're getting there. Okay? Let's try this solution that we got. Plug in 4/3. 3 times 4/3 will give me 4. What's 4 plus 1? 5. What's the absolute value of 5? Absolute value of 5. 5. Does 5 equal negative 5?
No.
Uh-oh. We made a mistake here. Can anyone find our mistake here? What about our C value on this slide? What did it say about our C value?
There's nothing has no solution.
In order for us to set up two equations, our C value has to be greater than or equal to 0, correct? Is that the case here? Is negative 5 greater than or equal to 0? No. What does it say happens if C is less than 0?
That's no solution.
Boom. We didn't need to do any of this work. I just wanted you guys to see what would happen if you tried to do the work. So, if we identify that our absolute value is set equal to a negative number, you can just write no solution, you're done. You don't have to do any work. Easy peasy. Right? So make sure you check that C value before you do any work. Does that make sense? If it's greater than or equal to 0, set up your two equations and solve them. If it's less than 0, no solution. Any questions on that? Sorry, but I wanted you guys to see what would happen if we continued on. If you were to continue this on, it's not the worst thing in the world. You just see that neither solution works, so you can say no solution at that point. Yes?
Is the C value always going to be on the opposite side of the equal sign?
Yeah, from the absolute value. So it could have been written like this. It's just the constant on the other side of the equal sign from the absolute value. Okay? Any questions about these two? Does that make sense for letter B? Why it's no solution? Because any number I plug in for x right here, it's inside the absolute value, so it's going to become a what kind of number? Absolute value will always be what kind of number? Positive. Will a positive number ever equal negative 5?
No.
No. So this is why it's no solution. Does that make sense?
Because if the number is negative.
Because my C value is negative, yes. Questions there? Questions on A or B? Let's move on. Absolute value of 3x plus 9 minus 10 equals negative 4. Solve the absolute value of 3x plus 9 minus 10 equals negative 4. No solution. Raise your hand if you think no solution here. That is incorrect in this case, and let me show you why. I know. I know. Hold on. It's going to make sense, I promise, hopefully.
If you put it positive, right?
On this first slide right here, we have the absolute value of ax plus b equals c, right? Outside of the absolute value, do we have anything being added to the absolute value?
No.
No. Do we have anything being subtracted from it?
No.
No. Do we have anything being multiplied by it?
No.
No. Do we have anything being divided by it?
No.
No. The absolute value is completely by itself on one side of the equation, right?
Yes.
Right? Okay. Is that the case here? No. What's with the absolute value? The minus 10, right? So what do you think we might need to do before we can determine if it's no solution or if I need to set up two equations? Add 10 to both sides, right? Get the 10 away from my absolute value. So, if I add 10, it's going to cancel out on that left-hand side, correct? Whatever I do to the left, I have to do to the right. So I get the absolute value of 3x plus 9 equals, what's negative 4 plus 10?
Negative 14.
That'd be 6. Okay? Now, is my absolute value by itself?
No.
Yes, there's nothing being added to it on the outside, nothing being subtracted from it on the outside, nothing being multiplied by it or divided by it, correct? So now, I can look at my C value. What is my C value? 6. Is that greater than or equal to 0 or less than 0? Greater than or equal to 0. So since it's greater than or equal to 0, can I set up two equations or is it no solution?
You can set up.
I can set up my two equations, right?
Yeah.
So, does that make sense to everybody?
Yeah.
Always, always, always make sure your absolute value is by itself. Okay?
So then you like do the same thing, but like make the 6 and then
That'd be my second equation, yes. What would my first equation be?
Take the bars out.
Yeah, take the bars away, right? 3x plus 9 equals 6. We okay with our first equation and how we got it? Get our first equation. It's the exact same without the bars. And what did we say our second equation was?
negative 6. Negative 6.
The exact same except making my C value negative. Everyone okay with that? From here, I can just solve my two equations and get my two solutions. Am I moving too fast for anybody? Okay. What's my first step on each of these to get x by itself?
Subtract 9.
Subtract 9 from both sides. Let's move our work up here. So on the left, I get 3x equals, what's 6 minus 9? Negative 3. On the right, I get 3x equals, what's negative 6 minus 9?
Negative 15.
Negative 15. We okay with that step? Now what's my next step on each of these to get x by itself?
Divide by 3.
Divide by 3. So on the first one, I get x equals negative 3 divided by 3.
Negative 1.
Negative 1. On the bottom one, I get x equals negative 15 divided by 3.
Negative 5.
Negative 5. We okay with how we got those two solutions? Okay, let's plug them in just to check. Plug them into our original. Negative 1 times 3 Negative 3. Negative 3 plus 9. 6. Absolute value of 6. 6. 6 minus 10. Negative 4. Does negative 4 equal negative 4?
Yes.
Yeah, this one checks out. Plug in negative 5. 3 times negative 5. Negative 15. Negative 15 plus 9.
Negative 6.
Negative 6. Absolute value of negative 6. 6. 6 minus 10. Negative 4. Does negative 4 equal negative 4? Yep, so this one checks out as well. Yep. So, for this first equation, I subtracted 9 from both sides. 6 minus 9 is? Negative 3. I got 3x equals negative 3. To get x by itself, divide by 3. X equals, what's negative 3 divided by 3? Negative 1. Okay. Any questions on example 2? So, make sure your absolute value is always, always, always by itself before you determine if it's no solution or if you can set up your two equations. Questions about that? How do you feel about this so far? Is this a little more difficult than what we've been doing? A little bit? We're getting the hang of it though, hopefully? No? Okay, well hopefully with more practice we will. Can I move on? Okay, moving on. I can come back to the slide if I need to. When you have an absolute value equation, it is possible for a solution to be what we call extraneous. An extraneous solution is an apparent solution, so it looks like one of our solutions, that must be rejected because it does not satisfy the original equation. That's why we check our solutions to make sure that each of our solutions work. Some of our answers may not be actual answers, and we cannot include them as an answer. Okay? That's why we got to check it. Are there any questions about what an extraneous solution is? Okay, let's look at an example. Solve the absolute value of 2x plus 12 equals 4x. Check your solution. Yes? Not right now. Solve the absolute value of 2x plus 12 equals 4x. Okay, very first thing we need to check is that our absolute value is by itself. So is my absolute value by itself, nothing being added to it, subtracted from it, multiplied by it, divided by it? Yes. Okay. Let's check our C value. What is our C value? 4x, correct? Is that greater than or equal to 0 or less than 0? Are you sure? You guys know what x is and you've already plugged it in? Oh, we don't know what x is, do we? So we don't know if it's greater than or equal to 0 or less than 0, do we? We're going to assume that it is greater than or equal to 0 and see what happens and set up our two equations. Okay? So what would my first equation be here? There you go. Exact same without the absolute value bars. Everyone good with that? What would my second equation be?
2x plus 12 equals -4.
There we go. 2x plus 12 equals negative 4x. Now I'm just solving these two equations. Our two equations now have a variable on both sides, right? So that's what we've been dealing with the past 2 days. If I've got a variable on both sides, what do I want to do? Get them to the same side, right? So on both of these, how would I get my variables to the same side?
Negative 2.
Subtract 2x from both sides. Mm-hmm. 4x minus 2x. 2x. Negative 4x minus 2x. Negative 6x. I'm going to let you catch up. I feel like I moved really fast through those steps. Is there any confusion up to this point on this problem about what we've done? Okay, on the left equation, what's my next step to get x by itself? Divide by 2. 12 divided by 2 gives me 6. So I get x equals 6. On the right equation, what's my next step to get x by itself?
Divide.
By
Negative 6
-6.
is negative
12 divided by -6 gives me -2. So there's my two solutions. That might be solutions. We need to check them to see if they are solutions.
If you times like 4x by negative 2, it'd be negative 8. So wouldn't it be no solution?
Not quite. Let's check our solutions to see if one or both of them works. Okay? You're on the right track. Okay? Can I erase my work that I've done to give myself room to plug in? Okay, let's plug in 6 first. So I've got to do what's in the absolute value bars first before I can take the absolute value. What's 2 times 6? 12. And 4 times 6 on the right.
24.
24. 12 plus 12. 24.
Oh, shoot.
It's all right. And then the absolute value of 24 gives me 24. Does 24 equal 24? Yep. So I know 6 is a solution. So it's not no solution in this case, right? I do have a solution. Let's check the other one to see if we have two solutions. Let's plug in -2. Okay, 2 times -2.
Negative 4.
-4. 4 times -2. -8. Someone's already noticed it earlier. But here we have an absolute value set equal to a negative number. So this one's looking like it's not going to be a solution. Let's carry it out just to make sure. -4 plus 12.
8.
8. And the absolute value of 8? 8. Does 8 equal -8? No. So is -2 a solution? No. I cannot include it in my answer. -2 is not a solution. It's what we call an extraneous solution, but I can't include it as my actual solution. So this problem only has one solution. Does that make sense? Any questions on that? How are we feeling? Terrible? Okay. There's no assignment tonight because my other classes are shortened by 10 minutes. So they would be finishing up right now. Class would be over. So I have not given them the assignment yet. So we'll get the assignment in class tomorrow. Let all this sink in your sleep tonight. You're going to be dreaming about absolute value equations tonight in your sleep. And then come tomorrow, you'll be nice and marinated thinking about all the absolute value equations you're going to be solving tomorrow. You're going to kill it. Okay? Are there any questions about any of the notes we just took? Okay?